Hello YouTube, this is Umozo3. For several videos, we've been building up a pretty robust understanding of different data structures, right? We've been comparing and contrasting different types of lists, okay? Now we've seen two different types of basically dictionaries. And we said that we can basically implement a set of key value pairs, either by using a hash map, which we studied about 11 lessons ago, or by using a hash table, which we studied about 2 lessons ago. So what we're going to do is open up a Hello World class, and you can see I've already imported 4 important Java classes, and this is often something that we have to do if we want to make use of important data structures. So we're going to be dealing with hash table, enumeration, iterator, and then I guess I don't need to import hash table twice. But let's go ahead and import list iterator, right? So we can go ahead and import the 3 types of iterators that we talked about, right? So we can go ahead and remind ourselves how these 3 types of iterators are distinct from one another, right? We first talked about the iterator, just the regular iterator, right? And you say for some list, you would say list.iterator, and then you could say, well, iterator.hasNext, right? We've seen this before. And then you could say something like, and then in the curly braces, you would say something like system.out.println of iterator.next. And we said one of the other features that the iterator provides is that you can actually optionally remove elements from the underlying data structure. Okay, so you could actually choose to remove elements from the data structure on which the iterator is based. And we've seen examples of that in previous videos. And then with an enumeration, this is a little bit more outdated. It's sort of called a deprecated class. I mean, we don't really use this interface. We don't really use this interface very much anymore because iterator is better, right? So this basically has the has more elements method and then the next element method. And it's like, why would you use those methods if you could just call shorter method names with an iterator? And the other benefit of an iterator over an enumeration is that the iterator also has the remove method. It's a void remove method that's available to iterator, but not to enumeration. And we said that list iterator is even stronger. So this can traverse the list forwards and backwards. Okay, so it has like a has next and it has a has previous, and we can go ahead and remind ourselves of some of the documentation of the list iterator interface. So you would go ahead and go to blackle.com and type list iterator Java. And you can just go ahead and do a Blackle search on that. So it's an iterator for list that allows the programmer to traverse the list in either direction, right? And you can also modify elements in the list. You could add elements to the underlying list. You could replace elements in the underlying list. But this really gives you a lot of control and manipulation over the underlying data structure. And that's not something that's available to a traditional iterator other than perhaps removing the element that you just referred to with next. So we talked about that in a previous video. And then with a hash table is very similar to a hash map, just like a vector is very similar to an array list, right? And so we could go ahead and remind ourselves of the documentation that we have here. So we could say hash table Java API and go ahead and remind ourselves, right? We did this in a previous video, but we said that this class implements a hash table which maps keys to values, and it's very similar to a hash map, okay? And so basically it says that it's recommended to use a hash map in place of a hash table. Okay, but it has the same collection of methods available to it. So you're really not that much worse off using a hash table. You still have all the same functionality and methods, right? You can see, you know, for some table, you could say dictionary.get of something, right? And that would return the value that's associated with that particular key. You could see if a hash table is empty, okay? You can also perform an iterator on the key set or an iterator on the values. And so that's what I want to practice a little bit more in this video. And then we also want to review the switch statement. Then we're going to talk about another type of queue. So now we know basically about 2 types of array lists, kind of, right? One of them is an array list and one of them is a vector. Now we sort of have 2 types of dictionaries. So now we have a hash map and a hash table. And then in this video, we're going to get a second type of queue. We already know queue of a particular type, my queue equals new linked list of a particular type. And that's how you would go ahead and declare and initialize a new queue. But you can also have something called a concurrent linked queue. And that's what we're going to be talking about in this video. But let's go ahead and remind ourselves of the iterators that we have available to us for different data structures. So with an array list, you can either call an iterator or a list iterator. Same thing with a linked list, iterator or list iterator, not an enumeration. There's no enumerations on array lists or linked lists. But with stacks, you can do an enumeration, right? We saw that the elements method is available to the stack class, right? If you go ahead and type in stack Java API, there's a method called elements, right? You can go ahead and let's see here. So it's actually, we said that stack is actually a subclass of vector. Okay, so that means Remember when we were talking about inheritance, we said that every subclass gets all the methods from the superclass. And so now if you look at vector, you see that vector has an elements method, which means that if a superclass has an elements method, presumably the subclass is going to have the elements method too. But the point is that you can have an enumeration on a stack. With a queue or a hash set, you can only have an iterator. There's no list iterator, there's no enumeration. With a hash map, you can either call an iterator on the keys or an iterator on the values. And we're sort of going to see an example of that, but on hash tables instead of hash maps. But you should be familiar applying the same takeaways from this video to an original hash map. And then we also have a vector. So a vector is just like an array list. Okay, and it has an iterator, a list iterator, and an enumeration. So you could argue that that's one thing that's actually better about a vector than an array list, is that it has an enumeration available to it, but that doesn't really add that many brownie points because you don't get anything out of an enumeration that you would get out of an iterator, and you don't get anything out of an iterator that you would get out of a list iterator, okay, that you would not get out of a list iterator. So then 3 iterator options for hash tables. So we can talk about that in this video. So iterator, you can have an iterator on the keys of the hash table. You can have an iterator on the values of the hash table, or you can have an enumeration on the elements of the hash table. And that would actually have the effect of enumerating on the values. So what we're going to do is create a hash table. And remember, we need to have 2 data types. So we need to have a data type for the keys and a data type for the values. So we're just going to map doubles to booleans, okay? And then we're going to call it my dictionary equals new hash table of type double and boolean, okay? So that's how you would declare and initialize a hash table, right? This is how you would create a new hash table, a new dictionary. Okay, very similar to a hash map, but now you just, I guess, have a lowercase t instead of a capital M. Okay, and then what you could do is you could say, we've seen this before, right? My dictionary dot put, and then you could have a double like 4.3, and then you would have to have like true, right? Because a boolean would probably either have to be true or false, right? And then you could say my dictionary dot put of 5.7 with false, right? So we can just do 3 key value pairs here, but the point, so I want to show you what's going on here. So we could say 5.9 and then true, because we said the keys have to be unique in a dictionary, but the values do not have to be unique. And we've talked about that in previous videos. And then what we're going to do is we're going to do an enumeration on the values. And the way that we do that is by calling the .elements method on the hash table. So you could say enumeration, and it would actually be on the booleans. It would be on the booleans, because we're saying that if you call an enumeration on a hash table, it enumerates, or I guess it enumerates on the values, okay? So that it would be of type boolean here, because we said that the type of the values here would be boolean. So we could say enumeration of type boolean, and then we could say x, let's call it x, equals my dictionary dot elements, okay? And then what you would do is you would say while x dot has more elements, right? So now we're reviewing the functionality that we have available in the enumeration interface, right? But it's kind of a long method name, okay? And then you would say system.out.println. Let's do not x.nextElement, okay? And so that would basically return the reverse of these 3 booleans. So instead of iterating through true, false, true, it should iterate through false, true, false, because we're just inverting it every time. So then if we go ahead and run it, that's what you see on the console, okay? So that's basically an example of how you can do an enumeration on a hash table, right? And then you could have also done an iterator either on the keys or on the values in particular. So the only thing that you would do here is you would say my dictionary dot key set, and then you would have to call an iterator on it, okay? And then this will be very similar. You can keep a lot of the same things here. We can still call it x, but now instead of has more elements, it would just be has next. And then instead of dot next element, it would just be dot next, right? And then it would just be, let's see what the issue is with this. So then I guess if we were calling an iterator on the keys, it would have to be of type double. So let's keep it booleans, but we'll iterate on the values. We'll iterate on the values. Okay, my dictionary.values.iterator. So again, we're going to do the same thing, but this is another way to achieve the same task as we just achieved 2 minutes ago now. So if we go ahead and run it, we get, again, you get false, true, false. What if you wanted to iterate through the keys? So you could say my dictionary.keyset.iterator. Okay, and then it wouldn't be an iterator of type boolean, it would be an iterator of type double, because the keys are doubles. And then, but the has next and the dot next, so those should still work, but it wouldn't make sense to say not x dot next, right? Because now x dot next is a double. rather than a Boolean. So now if you go ahead and compile it and then you go ahead and run it, you get 5.9, 5.7, and 4.3. And those aren't ordered, right? Those aren't the way that we necessarily added those elements to the dictionary. But we said that sets, the dictionary is a set of key value pairs. And we said that sets are characteristically unordered. So hopefully that's clear to you. And then what if we, just as another practice, what if we said my dictionary.replace of 5.7 with true? Okay, and then what if we, so this wouldn't really change the keys, but then let's go back and look at the values. So then we could say iterator of type Boolean x equals my dictionary.values.iterator. And then we can go ahead and compile it and we can go ahead and run it. So this is just showing you some of the functionality that's available to the hash table class. In the previous video, we talked about doing a switch statement with the char data type. So we can go ahead and review that very, very quickly, right? We're just going to say char A equals W, and then we could say switch of A. And then we could say basically case X, what if it's an X? You could say system.out.println of X, right? And then what if you say case W, and you'd say system.out.println of W? And then what if you say case P, and then you could say system.out.println of P? So hopefully you're pretty familiar with a switch statement this deep in the curriculum, but hopefully you can understand how this would work. And then you could have a default statement if you want as well. So what would be the output of this code? Well, it's going to latch on to the case W. And so you would print W and then P and then T, because we said that with the switch statement, we're going to print all subsequent cases unless we hit a break statement, just like we said with ints at the beginning of the curriculum. So you get WPT. What if you put a break statement after case P? Well, then we're not going to make it to the default. Then we're only going to print WP. Okay, what if it was something other? What if it was a space? What if your character was a space? Well, then you would just get the T, right? Then you're just going to go to the default case because the value that you're checking for doesn't match any of the possible case values. So we can go ahead and review that more in the next video, or you can practice it on your own. What we're going to do in this video is talk about another type of queue. So we've already learned about two types of array lists, basically, right? Array list or vector do essentially the same thing. We've already learned about two types of dictionaries. Hash map and hash table essentially do the same thing. Now we're going to learn about two types of queues. I guess we've already learned about one type of queue, right? But we can go ahead and remind ourselves of how queues work, right? This is a data structure that we talked about not too long ago, but it's basically a collection designed for holding elements in a first in, first out data structure. That's what it says here on the API. And we said that it basically amounts to holding people in line at a supermarket, which is the opposite of a stack, like a stack of dinner plates, which would be a last in, first out data structure. But anyway, what we're going to do is learn about another type of queue. And we already know that queues, we can add elements to the end of a queue. We can peek at the front of the queue without removing it. We can pull the front of the queue, so that would remove the head of the queue and return it. We can also, I guess this remove method would be pretty similar here, but we were talking mostly about the peek and the pull and the add method. And those are basically the three operations that you have available to you when you work with queues, right? Okay. And then what we can do is we can also think about another type of queue. So what you're going to do is we're going to go to blackle.com and we're going to type in concurrent linked queue. Okay, so we're just going to learn about a whole nother way to deal with queues. If you want a first in, first out data structure, there's two options that you have at your fingertips. Either you import queue and you create an object that's declared as a queue and initialized as a linked list, or you import java.util.concurrent linked queue. So this is actually what you have to import in order to use this class. And so this is actually something that I'm going to put here at the top. So we're going to say import java.util.concurrent linked queue. So note the .concurrent, okay? But this is how you make use of a concurrent linked queue. And it's just another type of queue that you have available at your fingertips, right? An unbounded thread safe queue based on linked nodes. And it says this queue orders elements first in, first out, or FIFO. Okay, and so the head of the queue is the element that has been on the queue the longest time, just like the regular queue that we talked about, right? Like the person who's at the front of the line in the supermarket has probably been waiting the longest amount of time at that instant, right? And then we can also think about some of the methods that we have available to a concurrent linked queue, and these are going to sound very familiar to you. Like we can see if a regular queue is empty, we can see if a concurrent linked queue is empty. We can add an element to a regular queue, we can add an element to a concurrent linked queue. And we have to remember that that method returns a Boolean. It's not a void method. It doesn't just add something to a queue, but it actually has the power to return a value, okay? But this is a class. So when we're talking about regular queues, a queue is just an interface. You can't initialize a queue, right? We said queue of a particular type, my queue equals new linked list of a particular type. It has to be initialized as a linked list, but a concurrent linked queue is just initialized as that. It's initialized as a concurrent linked queue. So the first thing you do is import the class, and then of course you create a concurrent linked queue. And so we're going to have an empty queue at the beginning, but we're going to say concurrent linked queue. You have to spell it all the way out. And then you would have to specify the data structure of the elements in your concurrent linked queue. Let's do strings. And then we could say my queue equals new concurrent linked queue of type string. And so this would declare and initialize a new queue. But this is just another queue that you have available to your fingertips, right? And so you could say my queue.add of tennis, okay? And then you could say boolean b equals my queue.add of hockey, okay? And so what we're doing is we're saying that the add method of the concurrent linked queue class technically returns a Boolean, right? If you look at the method description, it says that it inserts the specified element at the tail of the queue, but it also returns true, okay? You just get a true Boolean out of it. And we were sort of joking in a previous video, and we said if you ever want a true Boolean, just add an element to a data structure, right? Because that just returns true, okay? And then what if you said Boolean C equals not my queue.add of tennis, because we said that it's okay. So queues can have duplicate elements, right? Unlike sets, okay? And then we could say, we don't have to do Booleans for all of these, but what would this do? So then this line of code would assign C to false, but would add tennis to the end of the queue, okay? So it would have both of those effects. You're calling the add method, but you're assigning the result of it, you're assigning the opposite of the result of it to C, so that then C would be false, right? So then if you say system.out.println of B and C, we can check that. And then we could also say system.out.println of my queue.peak, and we could see the element that's at the beginning of the queue, right? And so let's just go ahead and add one more element just so that we don't have the same element at the beginning and the end. But what we could do, let's just do basketball. Okay, so pretty simple. And then what we're going to do is we're going to say system.out.println of my queue.peak. So hopefully you can predict that B and C, true and false, well, this would return false, right? Because C is false. But then if we peek at the front of the queue, this should be tennis, because that was the first element that was added to the queue that has not yet been removed. And so then if you go ahead and run it, you get false and tennis, and that's exactly what we predicted. And then we also talked about iterators. So what types of iterators do we have available to a concurrent linked queue? So we have an iterator here, and that's pretty much the only one. So just like we said, a regular queue only has an iterator. There's no list iterator, there's no enumeration. Same thing with a concurrent linked queue. There's just an iterator, and you can iterate through the elements in the queue if you want. Okay, but that's the only thing you can do. You can use an iterator. What can you do with an iterator? You can see if there's another element, you can get the next element, and you can remove an element from the underlying queue. That's it. There's no traversing it backwards or anything like that. Okay, and then you could say my queue.add of cup. Okay, and so then you could peek, but this would return tennis, but not remove it, right? Because we said that the peek method for a queue returns the front of the queue, but doesn't remove it. And so what we're going to do is create an iterator of type string, and you can call it W. And then what you would do is you would say my queue.iterator, and you just call it directly on the concurrent linked queue. It's an instance method called iterator that's called on an instance of the concurrent linked queue class. And then what you would do is you would say something like while w.hasNext, okay, and we have to spell next with a capital N, and then you could just say system.out.println, let's say w.next.to uppercase, okay, and then we could also go ahead and say it would just be w.remove, okay, and so we could just remove each of the elements from the queue as we iterate through them, right, and then we could just go ahead and see whether or not the queue is empty at the end. So you would say my system.out.println of my queue.is empty. So if we iterate through the elements in the queue and remove every single one of them until there's no more elements in the queue, then presumably the concurrent linked queue is going to be empty at the end of this method, and we would expect true to be the last thing that's printed on the console. So then if we go ahead and compile it, and then we go ahead and run it, you get false, tennis, right? Those were the first two things that we were printing. And then we printed out each of the 5 elements in the queue and the order that they were added. That's how a queue works. And then we just have true because the concurrent linked queue is empty after we remove each of the elements using the iterator on which the queue is based. So anyway, hopefully that was interesting to you, and we'll talk even more about advanced data structures in the next video. From Emails03, thanks for watching, and please subscribe.